Java Database Connectivity Architecture. Here you can see the architectural diagram of Java Database Connectivity. Java Database Connectivity JDBC is an application programming interface API for the programming language Java, which defines how a client may access a database. It is a Java-based data access technology used for Java database connectivity. It is part of the Java Standard Edition platform from Oracle Corporation. It provides methods to query and update data in a database and is oriented towards relational databases. A JDBC to ODBC bridge enables connections to any ODBC accessible data source in the Java Virtual Machine (JVM) host environment. Here you can see a two-tier architecture for data access. The JDBC API supports both two-tier and three-tier processing models for database access. Here in the two-tier model, a Java applet or application talks directly to the data source. This requires JDBC driver that can communicate with the particular data source being accessed. A user commands are delivered to the database or other data source, and the results of those statements are sent back to the user. The data source may be located on another machine to which the user is connected via a network. This is refers to as a client-server configuration, with the user machine as the client and the machine housing the data source as the server. The network can be an intranet, which, for example, connects employees within a corporation, or it can be the internet. Here you can see the client machine, which has the Java application and JDBC, and JDBC is connected to DBMS through DBMS proprietary protocol, and here database server, and you can see the DBMS here. In the three-tier model, commands are sent to the to a middle tier of services, which then sends the command to the data source. The data source processes the commands and then send the results back to the middle tier, which then sends them to the user. MIS directors find the three-tier model very attractive because the middle tier makes it possible to maintain control over access and the kinds of updates that can be made to corporate data. Another advantage is that it simplifies the deployment of applications. Finally, in many cases, the three-tier architecture can provide performance advantages. Until recently, the middle tier has often been written in languages such as C and or C or C++, which offer fast performance. However, with the introduction of optimizing compilers that translate Java bytecode into efficient machine-specific code and technologies such as enterprise Java Beans, the Java platform is fast becoming the standard platform for middle tier development. This is a big plus, making it possible to take advantage of Java's robustness, multi-threading, and security features. With enterprises increasingly using the Java programming language for writing server code, the JDBC API is being used more and more in the middle tier of a three-tier architecture. Some of the features that makes JDBC a server technology are its support for connection pooling, distributed transactions, and disconnected raw sets. The JDBC API is also what allows access to a data source from a Java middle tier. Here you can see the client machine GUI. It has a Java applet or HTML browser. Server machine, the business logic has application server Java, JDBC, HTTP, RMI, COBA, or other calls are passed from client machine to server machine and server machine to client machine. Here you can see the database server DBMS, and DBMS proprietary protocol is passed from server machine to database server and database server to server machine. And client machine interacts with server machine interacts with database server. The protocol for communicating with the database normally is not compatible across different databases. Therefore, there is a need for a product known as a database driver to convert the JDBC calls into the native call for the particular database. Needless to say, each database requires a different driver. Applications that use JDBC communicate to the database by using drivers. JDBC consists of two major sets of APIs, one for the application developers and another low-level JDBC Driver API for driver developers. JDBC drivers fit into four different categories. Here you can see JDBC Architecture Type 1 drivers. The original JDBC implementation simply leverage the features offered by ODBC drivers. Because ODBC had become quite popular, several ODBC drivers were already available in the market. Type 1 drivers use the existing ODBC drivers and provide a bridge which convert the JDBC API calls to ODBC API calls. These are commonly referred as the JDBC ODBC bridge. Previously using these drivers has performance implication because there is another layer ODBC to convert to. Another disadvantage is that ODBC native code must be loaded on the client machine. Because this type of driver uses native code, you cannot use them in an application such as an applet that works in the Java sandbox. Type 1 drivers are rarely used today. This figure outlines a simple JDBC architecture using this type of driver. This Type 1 JDBC drivers translate JDBC calls into ODBC calls. Type 1 JDBC drivers are usually called JDBC ODBC bridge drivers. Here you can see applications interacts with JDBC API. JDBC API interacts with driver manager and data source. Driver manager and data source interacts with JDBC ODBC bridge type 1 driver. JDBC ODBC bridge interacts with ODBC. ODBC interacts with DB client lib. DB client lib interacts with database. Here you can see JDBC architecture type 2 drivers. A type 2 driver converts JDBC calls directly into the client's API provided by the database without need for an intermediate ODBC layer. For this reason, these drivers offer better performance than type 1 drivers. Such drivers are known as native API partly Java drivers. Type 2 drivers communicate with the database by using the native client library provided by the database. This library is required to be loaded on the client machine. Because of this, applets cannot use these type of drivers. This architecture can be seen in this figure. Type 2 JDBC drivers translate JDBC calls into native DBMS APIs. Type 2 drivers consist of Java components and a native code component, which requires that binary code be loaded into each client machine. Here you can see applications interact with JDBC API. JDBC API interacts with driver manager and data source. Driver manager and data source interact with native API partly Java type 2 driver. Native API partly Java type 2 driver interacts with DB client library. DB client library interacts with database. Here you can see JDBC architecture type 3 drivers. These drivers follow the three tiered approach. To client server applications. The driver converts JDBC calls into the middleware protocol and is sent to the server middle tier. The calls are then converted to DBMS protocol inside the middleware and sent to the database. The middleware usually supports several databases, thus providing access to different databases to clients. Such drivers are usually referred to as the net protocol all Java drivers. This type of driver is usually useful for providing database access to applets directly. These drivers act as a proxy for database access by applets and other applications. This figure represents a typical architecture using type 3 driver. Type 3 JDBC drivers are pure Java drivers that use database middleware. Type 3 drivers communicate with database through middleware servers that must be running in the network. .NET protocol, the NET protocol allows the client JDBC drivers to be very small and load quickly. Fetching data rows may take longer because the data comes through middleware server. Here you can see applications interacts with JDBC API. JDBC API interacts with driver manager and data source. Driver manager and data source interact with net protocol all Java type 3 driver. Net protocol all Java type 3 driver interacts with middleware. Middleware interacts with database. Here you can see JDBC architecture type 4 drivers. Type 4 drivers, native protocol, all Java drivers talk pure Java. They are aware of the underlying protocol used by the database, and they communicate directly with the database without use of a middle layer. JDBC calls are converted into vendor specific DBMS protocols. These are the difference between type 4 and type 2 drivers is that these drivers are implemented fully using Java without the need for native libraries. Being pure Java provides very good performance compared to their mixed counterparts. Because no native code is used, these drivers may be used by applets. Your application obviously needs different drivers to communicate with different databases while using this type of drivers. This figure represents a simple architecture using a type 4 driver. Type 4 JDBC drivers are pure Java drivers that can access a database directly. Type 4 drivers are sometimes called thin drivers. Type 4 the JDBC drivers have relatively fast performance. Here you can see applications interacts with JDBC API. JDBC API interacts with driver manager and data source. Driver manager and data source interact with native protocol or Java type 4 driver. Native protocol or Java type 4 driver interacts with database. Now we are focusing on Java application. The Java application, the application written in the Java programming language is responsible for interacting with the user and for invoking JDBC API functions. These API functions submit SQL statements for processing by a file system or a database management system. The Java application uses interfaces, classes, and methods that are defined by the Java API to access data source. Here you can see Java and the database. JDBC is a SQL level API, one that allows you to execute SQL statements and retrieve the results, if any. API itself is a set of interfaces and classes that designed to perform actions against any database. The interface result set, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. Interface statement, the object used for executing a static SQL statement and returning the result it produces. By default, only one result set object per statement object can be open at the same time. Therefore, if the reading of one result set object is interleaved with the reading of another, each must have been generated by different statement objects. All execution methods in the statement interface implicitly close a current result set object of the statement if an open one exists. Interface prepared statement, an object that represents a precompiled SQL statement. A SQL statement is precompiled and stored in a prepared statement object. This object can then be used to efficiently execute this statement multiple times. Interface callable statement, the interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes a result parameter and one that does not. If used, the result parameter must be registered as an out parameter. The other parameters can be used for input, output, or both. Parameters are referred to sequentially by number, with the first parameter being 1. Interface connection, a connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. A connection object's database is able to provide information describing its tables, its supported SQL grammar, its stored procedures, the capabilities of this connection, and so on. This information is obtained with the get metadata method. You can see here class driver manager, the basic service for managing a set of JDBC drivers. Here you can see result set is connected to statement. Here result set is connected with connected to prepared statement. Result set is connected to callable statement. Statement, prepared statement, callable statement interacts with the connection. Connection interacts with driver manager. Driver manager interacts with Oracle driver or JDBC or DBC bridge and Sybase driver here. Oracle driver interacts with Oracle database. JDBC or DBC bridge interacts with ODBC driver. ODBC driver interacts with ODBC database. Sybase driver interacts with Sybase database. As an example, we can consider here Java database connectivity. Java database connectivity, JDBC API. The Java database connectivity JDBC API provides universal data access from the Java programming language. Using the JDBC API, you can access virtually any data source, from relational databases to spreadsheets and flat files. JDBC technology also provides a common base on which tools and alternative interfaces can be built. Packages include java.sql, javax.sql. As example 2, we can consider module java.sql defines the JDBC API. Here you can see the module graph. Java.sql here you can see Java.sql module. This module exports Java.sql package and javax.sql package. Indirect exports java.util.logging package from java.logging module. javax.transaction.exe package from java.transaction.exe module, and javax.xml, javax.xml.catalog, etc. from java.xml package, our java.xml module. So java.sql module requires java.logging module defines the Java logging API, and java.sql module requires java.sql XML module defines the Java API for XML processing, JAXP, the streaming API for XML, STAX, the simple API for XML, SAX, and the W3C document object model, DOM API. And Java.xql module requires java.transaction.xa module, defines an API for supporting distributed transactions in JDBC. Java.logging and java.xml and java.transaction.xa modules requires java.base module, defines the defines the foundational APIs of the Java SE platform. As an example 3, we can consider package java.sql, provides the API for accessing and processing data stored in a data source, usually a relational database, using the Java API, Java programming language. This API includes a framework whereby different drivers can be installed dynamically to access different data sources. Although the JDBC API is mainly geared to passing SQL statements to a database, it provides for reading and writing data from any data source with a tabular format. The reader-writer facility available through the javax.sql.rowset group of interfaces can be customized to use and update data from a spreadsheet, flat file, or any other tabular data source. This package is in module java.sql. This package, the java.sql package contains APIs for the following: making a connection with the database via the driver manager facility, includes a driver manager class, SQL permission class, driver interface, driver property info class. Sending SQL statement to a database, statement, prepared statement, callable statement, connection, interface, and save point. Next point is retrieving and updating the results of a query, result set interface. Next point is standard mappings for SQL types to classes and interfaces in the Java programming language. Array interface, blob interface, club interface, date class, enclub interface, ref interface, row ID interface, struct interface, SQL XML interface, time class, timestamp class, and types class. Next point is custom mapping and SQL user defined type UDT to a class in the Java programming language, SQL data interface, SQL input interface, and SQL output interface. Next point is metadata, database metadata interface, result set metadata interface, and parameter metadata interface. Next point, the last point is exceptions, SQL exception, SQL warning, and batch update exception. As an example 4, we can consider the module, the package javax.sql provides the API for server-side data source access and processing from the Java programming language. This package supplements the java.sql package, and as of the version 1.4 release is included in the Java Platform Standard Edition Java SE. It remains an essential part of the Java Platform Enterprise Edition Java EE. This package is in the module java.sql. The javax.sql package provides for the following. 1. The data source interface as an alternative to the driver manager for establishing a connection with the data source. 2. Connection pooling and statement pooling. 3. Distributed transactions. 4. Row sets. Applications use the data source and row set APIs directly, but the connection pooling and distributed transactions APIs are used internally by the middle tier infrastructure. As an example 5, we can consider this code segment. Here you can see a interface connection, a connection session with a specific database. SQL statements are executed and results are returned with the context of a connection. Interface statement, the object used for executing a static SQL statement and returning the results it produces. Here in create statement, creates a statement object for sending SQL statements to database. Here the execute query method execute the given SQL statement, which returns a single result set object. Here the result set interface, a table of data representing a database result set, which is usually generated by executing a executing a statement that queries the database. Here the next moves the cursor forward one row from its current position, and here the get int retrieves a value of a designated column in a current row of this result set object as an int in the Java programming language. In get string retrieves the value of the designated column in the current row of this result set object as a string in the Java programming language. Here get float retrieves the value of the designated column in the current row of the of this result set object as a float in the Java programming language. In the following example of setting a parameter, Con represents an active connection. The interface prepared statement, an object that represents a precompiled SQL statement. We can consider this code segment as example 7. STMT is the callable statement. Here the interface callable statement, the interface is used to execute SQL stored procedures. The JDBC API provides the stored procedure SQL escape syntax that allows stored procedure to be called in a standard way for RDBMS. This escape syntax has one form that includes a result parameter and one form does not. If used, the result parameter must be registered as an out parameter. The other parameters can be used for input, output, or both parameters. Parameters are referred to sequentially by number, with the first parameter being 1. Here the register the out parameter before calling the stored procedure. They read the out parameter now. As an exception example, we can consider SQL exception, the class SQL exception, an exception that provides information on a database access error or other errors. This is in the module java.sql and in the package java.sql. As an error example, we can consider JDBC connection errors in the environment with IBM Netcool Omnibus. The description is connection errors are typically caused by incorrect or invalid connection with string parameters, such as invalid hostname or database name. The action is to verify that you are using correct and valid connection string parameters for the get.jdbc.url property. Now we are focusing on JDBC driver manager, the basic service for managing a set of JDBC drivers. note, the data source interface provides another way to connect to a data source. The use of a data source object is the preferred means of connecting to a data source. As an example, we can consider class driver manager, the basic service for managing a set of JDBC drivers. Not the data source interface provide another way to connect to a data source. The use of a data source object is the preferred means of connecting to a data source. This is in the module java.sql and package java.sql. As a part of the initialization, the driver manager class will attempt to load available JDBC drivers by using point 1, the JDBC.drivers system property, which contains a colon separated list of fully qualified class names of JDBC drivers. Each driver is loaded using the system class loader. The point 2, system providers of the java.sql.driver class that are loaded via the service provider loading mechanism. As an example 2, we can consider this code segment. Register by using a system property. Each virtual machine has its own method of setting system properties. For example, the Java command from the JDK uses the -d option to set system properties. To set the driver using system properties, specify this following here. This is the fully qualified class names, class name of the JDBC driver here, com.ibm.as400.access.as400 JDBC driver here. As an example 3, we can consider this code segment. Register by using the Java program to load IBM toolbox for Java JDBC driver at the following to the Java program before the first JDBC call. Here the method public static class question mark and the for name string class name throws class not found exception. This returns the class object associated with the class or interface with the given string name. Invoking this method is equivalent to class for name class name through current loader, where current loader denotes the defining class loader of the current class. For example, following code segment returns the runtime class descriptor for the class name java.lang.thread here. A call for the for name x causes the class name x to be initialized. As an example 4, we can consider this one, this code segment, registering JDBC driver. You can explicitly register the IBM toolbox for Java JDBC driver by using following. The method public static void register driver throws SQL exceptions, registers the given driver with the driver manager. A newly loaded driver class should call the method register driver to make itself known to the driver manager. If the driver is currently registered, no action is taken. As an example 5, we can consider this code segment connecting to the server database and specifying user ID and password. The method public static connection, get connection, string URL, string user, string password attempts to establish a connection to a given database URL. The driver manager attempts to select an appropriate driver from the set of registered JDBC drivers. Note, if the user or password property are also specified as part of the URL, it is implementation defined as to which value will take precedence. For maximum probability or maximum portability, an application should only specify a property once. As an exception example, you can consider SQL exception. If a database access error occurs or the URL is null in method public static connection, get connection, string in class driver manager. As an error example, we can consider this one: invalid JDBC URL JDBC :MySQL Aurora //YYY Aurora.xxxx.com :3306 / some DB name here, and URL prefix must be JDBC :JD //. Now we are considering data source. A data source is a Java object that implements the javax.sql.data source interface. The data sources offer a portable and vendor-independent method for creating JDBC connections. Data sources are factories that return JDBC connection to a database. J2EE applications use JNDI to look up data source objects. Here in JDBC Architecture, JDBC Architecture type 1 drivers, you can see the data source here. Data source interact with JDBC API and JDBC or DBC bridge type 1 driver here. In type 2 drivers, you can see the data source here. Data source interacts with JDBC API and native API partly Java type 2 driver here. In type 3 drivers, you can see data source here. Data source interacts with JDBC API and net protocol or Java type 3 driver here. In type 4 drivers, you can see data source here. Data source interacts with JDBC API and native protocol or type for driver. As an example, we can consider interface data source, a factory for connections to the physical data source that this data source object represents. An alternative to the driver manager facility, the data source object is the preferred means of getting a connection. An object that implements the data source interface will typically be registered with a naming service based on the Java naming and directory JNDI API. This is in the module java.sql and in the package java.sql. The data source interface is implemented by the driver vendor. There are three types of implementation. One, basic implementation produces a standard connection object. Two, connection pooling implementation produces a connection object that will automatically participate in connection pooling. This implementation works with a middle tier connection pooling manager. 3, distributed transaction implementation produces a connection object that may be used for distributed transactions and almost always participate in connection pooling. This implementation works with the middle tier transaction manager and almost always with the connection pooling manager. As an example, we can consider this code segment. After a basic data source implementation is deployed by the system administrator, it is ready for programmers to use. This means that a programmer can give a logical data source name that was bound to an instance of a data source class. The JNDI naming service will return an instance of that data source class. The method getConnection can then be called on that data source object to get the connection of that data source object to get the connection to the data source it represents. For example, a programmer might write this type of code here. First line of this code here, this line gets an initial context as the starting point for retrieving a data source object. When you supply the logical name here JDBC fast coffee DB at deployment time, on the when you supply the logical name JDBC /fast coffee DB to the method lookup, the method returns the data source object. That the system administrator bound to the JDBC /fast coffee DB at deployment time. Because the return value of the method lookup is a Java object, we must cast it to the more specific data source type before assigning it to variable ds. The variable ds is a connection, is an instance of the class that implements the data source interface. Calling the method ds.getConnection produces the connection to the database. GetConnection method requires only the username and the password because the variable ds has the rest of the information necessary establishing the connection with the database here. And here the connection pool data source object are deployed. A programmer can use a data source object to get the pool connection here. The code for getting the pool connection is just like the code or for getting non-pool connection. You can see here the variable ds represents a data source object that produces the pool connection to the database coffee break. You need to retrieve the data source object only once, because you can use it to produce as many pool connections as needed. Calling method get connection on ds variable automatically produces the pool connection, because the data source object that ds variable represent was configured to produce the pool connections. Connection pooling is generally transparent to the programmer. There are only two things you need to do when you are using pool connections. Use data source object rather than the driver manager to get a connection. In this code, ds is a data source object implemented and deployed so that it will create pool connections, and username and passwords are variables that represent the credentials of the user and user that has access to the database. And use finally statement to close pool connection. This finally block would appear after try catch block that applies the code in which pool connection was used. Yeah. Otherwise, an application using pool connection is identical to the application using regular connections. Only other thing an application programmer might notice when connection pooling is being done is that performance is better. As an exception example, we can consider SQL exception. If a database access error occurs in the method connection get connection in interface data source. As an error example, we can consider this error occurred in the environment with GZD and JDBC. The data source configuration failed, WAX72091 connected to the process server 1 on node, etc. Now we are focusing on JDBC Driver. A JDBC Driver is a software component enabling a Java application to interact with a database. JDBC drivers are analogous to ODBC drivers, ADO.NET data providers, and OLEDB providers. Here you can see JDBC driver types. Type 1 JDBC driver. Type 1 JDBC drivers translate JDBC calls into ODBC calls. Type 1 JDBC drivers are usually called JDBC ODBC bridge drivers. Type 2 JDBC driver Type 2 JDBC drivers translate JDBC calls into native DBMS APIs. Type 2 drivers consist of Java component and native code component, which requires that binary code be loaded on each client machine. Type 3 JDBC drivers are pure Java drivers that uses database middleware. Type 3 drivers communicate with the database through middleware servers that must be running in the network. The net protocol allows the client JDBC drivers to be very small and load quickly. Fetching data rows may take longer because the data comes through middleware server. Type 4 JDBC driver. Type 4 JDBC drivers are pure Java drivers that accesses a database directly. The Type 4 drivers are sometimes called the thin drivers. Type 4 JDBC drivers have a relatively fast performance. Here you can see type 1, 2 and 3 and 4 drivers. In type 1 you can see in client here Java client or JDBC or DBC bridge and JDBC drivers are there. Java client is connected to JDBC ODBC bridge, and JDBC ODBC bridge is connected to ODBC driver, and ODBC driver interacts with data source. In type 2 you can see Java client, JDBC native library and native library are inside client tier. Java client is connected to JDBC native library. JDBC native library is connected to native library, and native library interacts with data source. Here Java client is inside the client tier. Java client is connected to middle tier. App1 applications and application server and three tier JDBC driver are in middle tier. Middle tier is connected to data source. In type 4 Java client and all Java JDBC driver are inside client tier, and Java client is connected to all Java JDBC driver, and all Java JDBC driver interacts with data source. As an example, we can consider this database connection URL in MySQL, where localhost is the name of the server hosting your database and 3306 is the port number. Here you can see the syntax here. In here host : port is the host name and port number of the computer hosting your database. If not specified, the default values of host and port are 127.0.01 and 3306 respectively. Database is the name of the database to connect to. If not specified, the connection is made with no default database. Failover is the name of the standby database. MySQL connector /J supports failover. Property name equal property value represent an optional ampersand separated list of properties. These attributes enable you to instruct MySQL connector /J to perform various tasks. As an example 2, we can consider this database connection URL in Java DB. You can see the syntax here. Here in sub protocol is specified where the Java DB should search for the database either in a directory, in memory, in a class path, or in a jar file. It is typically omitted. Database name is the name of the database to connect to. Attribute equal value represent an optional semicolon separated list of attributes. These attributes enable you to instruct Java DB to perform various tasks, including following. Point 1, create database specified in the connection URL. Point 2, encrypt the database specified in the connection URL. Specify directories to store logging and trace information. Specify a username and a password to connect to the database. As the example 3, we can consider this driver for this is for PostgreSQL. Before JDBC version 4 and Java SC 1.6, there was no generic mechanism in the JVM that would enable services to be discovered and registered automatically. Because of that, the manual step was needed to load the JDBC driver class by name. Here, the method public static class dot forName string class name throws a class not found description here. If there's an error, and this method returns the class object associated with the class or interface with the given string name. Here a call for name causes the class name here this one to be initialized. As the example 4, we can consider this driver oracle.jdbc.driver.oracle driver. Here this class for Oracle database. As the example 5, we can consider the driver class for the Sybase database, sybase.jdbc.sqlanywhere.idriver. As the example 6, we can consider this one. Here is an example of using tpipe to write the results of an SQL query on a table in MySQL database. The MySQL connector J is the official JDBC driver for MySQL. Once you have extracted the distribution archive, You can install the driver by placing MySQL connector java version bin.jar in your class path, either by adding the full path to your class path environment variable or by directly specifying it with the command line switch cp when starting the JVM. As an exception example, we can consider class not found exception in if the class cannot be located in the method for name string class name in class As an error example, we can consider this error occurred in the environment with MySQL on Tomcat 7.0 server. The error is com.mysql.jdbc.driver occurred as a result of class not found exception. Now we are focusing on database. Database, also called electronic database, any collection of data or information that is specially organized for a rapid search and retrieved by a computer. Databases are structured to facilitate the storage, retrieval, modification, and deletion of data in conjunction with various data processing operations. A database management system, DBMS, extract information from database in response to queries. Here you can see architecture of the Oracle JDBC drivers and Oracle database. The in addition to supporting the standard JDBC application programming interfaces APIs, Oracle drivers have extensions to support Oracle specific data types and to enhance performance. JDBC Thin Driver. The JDBC Thin Driver is a pure Java type 4 driver that can be used in applications and applets. It is a platform independent and does not require any additional Oracle software on the client side. The JDBC Thin Driver communicates with the server using SQL*net to access the Oracle database. The JDBC Thin Driver allows a direct connection to the database by providing an implementation of SQL*net on top of Java sockets. The driver supports the TCP/IP protocol and requires a TNS listener on the TCP/IP sockets on the database server. JDBC OCI driver. The JDBC OCI driver is a type 2 driver used with Java applications. It requires an Oracle client installation and therefore is Oracle platform specific. It supports all installed Oracle net adapters including IPC, named pipe, TCP, IP, and Internet Work Packet Exchange, Sequence Packet Exchange, IPX, SPX. JDBC OCI driver, written in combination of Java and C, converts JDBC invocations to call OCI using native methods called to C entry points. These calls communicate with database using SQL*net. The JDBC OCI driver uses OCI libraries, C entry points, OracleNet, call libraries, and other necessary files on the client computer where it is installed. OCI is an API that enables you to create applications that use the native procedures or functions calls to the third generation language to access Oracle database, and control all phases of SQL statement processing. JDBC server-side thin driver. JDBC server-side thin driver offers the same functionality as the JDBC thin driver that runs on the client side. However, the JDBC server-side thin driver runs inside the Oracle database and accesses a remote database or a different session on the same database. This driver is useful in following scenarios: accessing a remote database server from Oracle database instance acting as a middle tier, accessing an Oracle database session from inside another, such as from a Java stored procedure. The use of JDBC thin driver from the client application or from inside the server does not affect the code. JDBC server-side internal driver. The JDBC server-side internal driver supports any Java code that runs inside the Oracle database, such as in Java stored procedures or enterprise Java Bean EJB, and must access the same database. It lets the Java virtual machine JVM to communicate directly with the SQL engine. The driver supports only JDK 1.4.1. The JDBC server-side internal driver, the Oracle JVM, the Oracle database, and SQL engine all run within the same address space, and therefore the issue of network round trips is irrelevant. The program access the SQL engine by using function calls. The JDBC server-side internal drive is fully consistent with the client-side drivers and supports the same features and extensions. Here you can see JDBC thin driver and is connected with the and Java sockets. Java sockets interacts with SQL engine, PL/SQL engine. Here you can see JDBC OCI driver, OCI C library interacts with SQL engine and PL/SQL engine. PL/SQL engine and Java engine and KPRBC library are inside Oracle database. SQL engine and PL/SQL engine interacts with Java engine and RBC library. Server-side thin driver and JDBC server-side internal driver are inside Java engine, and Java engine interacts with JDBC server-side internal driver interacts with KPRBC library, and Java engine that server-side thin driver interacts with Oracle database in another Oracle database. As an example, we can consider connecting to MySQL database. You can see the database connection URL here, and syntax is here. Here host and port is the host colon port is the host name and the port number of the computer hosting your database. It is not specified. The default values of host and port are 127.0.0.01 and 3306 respectively. Database is the name of the database to connect to. If not specified, the connection is made with no default database. Failover is the name of the standby database. MySQL connector J supports failover. Property name equal property value represent an optional ampersand separated list of properties. These attributes enable you to instruct MySQL connector J to perform various tasks. As an example 2, we can consider this one. This is to connect to PostgreSQL database. There are different URL forms here. You can see those are here. Here the host name of the server default to localhost. So to specify an IP version 6 address, you must enclose the host parameter with square brackets and here the port number the server is listening on default to the PostgreSQL standard port number 5432 and database. The database name default is to connect to a database with the same name as the username. And in addition to the standard connection parameters, the driver supports a number of additional properties which can be used to specify additional driver behavior specific to PostgreSQL. These properties may be specified in either connection URL or additional properties objects. Parameters to driver manager.getConnection. Here user, the database user on whose behalf the connection is being made here. Password, the database user's password. SSL, the connect using SSL. The server must have been compiled with SSL support. This property does not need a value associated with it. The mere presence of it specifies a SSL connection. However, for the compatibility with future versions, the value is true, is preferred. As the example 3, we can consider this URL to connect to a Oracle database. You can see the syntax here. The first part of the URL specifies which JDBC driver is to be used. The supported driver type values for client-side applications are thin and OCI. The brackets indicate that the username and password pair are optional. The database specifier value identifies the database to which application is connected. Here you can see the host name. Port number and SID. We can consider this one, this URL to connect to Sybase database. You can see JDBC Sybase TDS. This is the host name and port and In the syntax there can be /database here, and connection underscore property values. As an example 5, we can consider this one with Quarkus JDBC data source at the agrowal extension plus one of JDBC DB2, JDBC Derby, JDBC H2, JDBC MariaDB, JDBC MS SQL, JDBC MySQL, JDBC Oracle, or JDBC PostgreSQL. Then configure your data source. As here, here the database kind define which type of database you will connect to. Here PostgreSQL. Here database credentials. Here configuring your JDBC connection the JDBC URL, and here the connection pool size. As an exception example, we can consider PSQL exception. The class PSQL exception is in package org.postgresql.util. As an error example, we can consider this error: this connection has been closed at org.postgresql.jdbc2.abstract JDBC2 connection. Check close at etc. This is end of the my presentation. Thank you very much for watching it.